Welcome to lesson 2. This is Terraform 0 to Hero. I'm your instructor, Evan Curtis. In this lesson, we're going to talk about multi-cloud deployment and state. So in Terraform, we have this concept of multi-cloud deployment. It's attractive to spread infrastructure across multiple clouds. By using only a single region or a single cloud provider, fault tolerance is limited to the availability of that provider. So that's not really a great situation to be in if something goes wrong. So we can improve our fault tolerance by spreading it across multiple clouds, multiple regions. This also increases availability. The other benefit of Terraform is that it is cloud agnostic. This simplifies the management and orchestration, helping operators build large-scale multi-cloud infrastructure. So this is definitely a huge benefit of Terraform, is that we can deploy to OCI, GCP, Azure, AWS, and we can spread our infrastructure across all of those clouds. Next thing we want to talk about is Terraform State. So state is a necessary requirement for Terraform to function. Terraform requires some sort of database to map Terraform configuration to the real world, saying, hey, here's this configuration, and this is what I think is actually out there in the real world, and then verifying that with a database. And so that's a mapping to the real world. We really need to make sure that the resource that we're declaring here, in this case, an AWS instance, is a real EC2 instance. So we have an identity that's tied to that. Terraform expects each remote object to be bound to only one resource instance, which is normally guaranteed by Terraform being responsible for creating objects and recording their identities in the state. An ambiguous state is when one or more remote objects are bound to two or more resource instances, for example. So we really want to avoid ambiguous state. That's not a good situation to be in. The other thing that Terraform tracks is the metadata. So we know what dependencies each resource has. For example, an S3 bucket could possibly depend on an IAM policy document that specifies read and write access for something like CloudTrail. So we use metadata to track those resource dependencies. Great benefit of Terraform is we use this ability to cache to improve performance. So when we run Terraform plan, we know the current state of the resources, and we're allowed to, we can cache that so that the next time that we run it, it's even faster. So we're caching the attribute values for all the resources in the state. This improves performance and allows us to rapidly run Terraform plans. Next concept is syncing. So how do we handle the process of synchronizing our plan with what's in the cloud? Well, remote state is a solution to this problem. We use remote locking to avoid two or more different users running Terraform. So when you run Terraform apply, the state is locked. So we can't have someone running Terraform. We can't have two users running Terraform simultaneously. That's it for lesson 2. I hope that you enjoyed this lesson here and keep on learning Terraform.